Hello, today's 10.2 and we're going to talk about circles and regular polygons, the area and circumference and perimeter of those. Circles I don't think you'll have too much problems with because you've been dealing with areas and circumference of circles since elementary school. Regular polygons we have to deal with apothems, so that might be a little bit slower going. Let's start with circles. A circle is defined as the locus of points in a plane that are a fixed distance from a point called the center of the circle. Okay? And then you name a circle by this little symbol and then whatever letter is its center. So your circumference is going to be pi times diameter, or you could write it as pi times 2 times radius, because 2 times radius is the same thing as diameter. And your area is pi times r squared. So let's find the area of circle K in terms of pi. Terms of pi means that you're not going to get a decimal approximation. You're going to leave it so that it is exact. So pi will be in your answer. Okay? So area is going to be, I suppose I should write this, pi r squared. So our radius is 3 because our diameter is 6, so 3 squared. So I'm going to write this as my area is 9 pi inches squared. Let's move on to 1b. This one has algebra in it. It says find the radius if their circumference is 65x plus 14 pi. So circumference, right over here, circumference is, since we're looking for radius, I'll write it like 2 pi r. They give us the circumference of 65x plus 14 pi equals 2 pi r. And we need to find the radius. So we're going to divide out pi and 2, and then we'll have our answer. If I divide pi on both sides, it just gets rid of it. So that's what I do first. I kind of cancel out the pi's right away. And then I'm going to divide by 2. So 65x divided by 2, I believe that's 32.5x. And 14 divided by 2 is 7. So this, and it's meters, is our radius. And that's the answer. 1c, it says find their circumference if the area is this. Okay, so this is a little bit more investigative work. So you know your area, which is pi r squared, and we need to know the circumference, which is going to be, I'll just write pi times diameter. Okay. So what we need to know is the diameter, or once we find the radius, we'll know the diameter. So let's take this information and find the radius. So our area is 25x squared pi, and that equals pi r squared. Well, I think you can almost see this right away. Let's divide out our pi's, and then we're left with 25x squared equals r squared. Well, to find just r, we need to take the square root. So that leaves me with 5x equals r. Well, great. Now I know what 5x is my radius, then I'm able to solve for my circumference. So my circumference is going to be pi times diameter. Well, diameter is just 2 times radius. So pi times 2 times 5x, which gives me 10x pi feet. That is my circumference. Another one. It says find the area in terms of pi when the circumference equals this. So now this time we're given the circumference and we need to find the area. So again, we'll basically have to find the radius. So we'll use this information. Circumference is, I'll write it as 2 pi r, and area is pi r squared. We know the circumference, it's 4x minus 6 pi. And then I'm going to divide out my pi's, and then I'll divide by 2. When I divide 4x minus 6 divided by 2, I get 2x minus 3, and that's my radius. Well, I need to know my radius, so I'm going to plug it in here. So I have area equals pi times 2x minus 3 squared. And I have no idea if they want you to actually write this out, but if you do, you need to FOIL it, remember? So you're going to have 2x minus 3 times 2x minus 3. So you have 4x squared minus 6x minus 6x, so minus 12x plus 9. And that's going to be pi. And the label is meters squared since it's area. So that would be your final answer. Let's move on to regular polygons because this stuff will be a little bit more difficult with the apothems. So, do recall a regular polygon has all the same length sides. Okay? And you'll have to remember what each one's called. A pentagon's 5 sides, a hexagon's 6 sides. If you've forgotten, maybe look them up and jot them down so you have them. The center of a regular polygon is equidistant from the vertices. Okay? That's saying right here, like the C, that's the same distance to D as it is to H, to G, etc. The apothem is the distance from the center to a side. That's this dotted line. Okay? And that is perpendicular to the side. A central angle of a regular polygon has its vertex at the center and its side passes through consecutive vertices. Each central angle measure of a regular n-gon is 360 divided by n. So in this case here, so your central angle is just going to be like right here, or right here, or right here. They're all the same. So since this is a pentagon, which is 5 sides, you're going to take 360 divided by 5 to get the measure of this. And I might just write that. That's a 0. To get that angle measure right there. Okay. All right, so we do need to remember that this formula, so the area of a regular polygon, and the apothem is A, and the perimeter is big P, or uppercase P, you're going to have 1/2 times the apothem times the perimeter. So let's find the area of a regular heptagon with side length 2 feet to the nearest 10th. So what I unfortunately like to do is draw these out, and you know how great I am with drawing. So we'll see how this goes. 2, 3, 4, 5, 6, 7. Yep, that's pretty. Okay. The side length is 2. So I have 2, 4, 6. I have 14 feet for my perimeter, and I'm just going to jot that down right here because I'll need that. Okay. And we need to find the area. So here's my center, and I have these central angles here, which are 7 of them. And they are totally equal, as you can see. I'm going to write down my formula for this regular polygon. 1/2 times A times perimeter. Well, it looks like we know the perimeter, but we need to find the apothem. Now, the apothem is that dotted line right here, okay, where this is a right triangle. So I'm going to take just this part. Actually, I'm going to take a different color and show you this here. That's what I'm going to pull out, and I'm going to pull it out right here so it's a little bit easier to see. So since my side length is 2 and this is half my side length, this is a 1. Okay? We don't know what this is right here. This is the apothem. That's what we're looking for. But we do actually know what the degrees is right here. So I'm going to switch colors again because this is getting kind of crazy. So we need to find the central angle, which is 360 divided by the number of sides. And then we'll need to take half of that because the central angle would be the whole thing, and this is half of that central angle. So you're going to take 360 divided by 7, and then you're going to divide by 2 again. Okay, I have no idea why that didn't pause, but I just want to make sure that I had the right number. So 360 divided by 7 gives you like 51.4 if you round it, and then you divide it by 2, you get 25.7. So that's the number of degrees we'll use. That is the number of degrees right here. So we still need to find A. To find A, we're going to have to use trig functions because we know an angle and we know a side, so we can figure out this side. So to find the apothem, we know the angle and we know its opposite and we need to know its adjacent. So I would use tangent of 25.7 equals opposite over adjacent. Okay. So when I multiply, or when I divide 1 divided by tangent 25.7, 1 divided by tangent 25.7, I get 2.08 about. Okay, so that's my apothem. Now I have enough information to plug in. So I have my area, I'll go back to black, is equal to 1/2 times A, which we found is about 2.08, times P, which we found right away as 14. I'm going to plug that into my calculator, and I get about 14.5. That is my area of this heptagon. What is the label? Feet squared. We'll do another one. And this one says, find the area of a regular dodecagon with side length 5 centimeters to the nearest tenth. I am not drawing a dodecagon. That is 12 sides. I had struggled enough with 7 sides. So I'll just have to draw this little triangle part in there. That's what I will do. Okay. If the side length is 5 centimeters, that means this part right here is 2.5. And we can find the angle because it's 360 divided by 12, which is 30. My 3 suck. Divided by 2. So I have 15 degrees is this right here. So I have enough information to find my apothem. And I can do tangent of 15 equals 2.5 divided by A. So I'm going to take 2.5 and divide by tangent 15. I get 9.3 about. Go slow on those. And then I need to find my perimeter, which I have 5 times 12, so my perimeter is 60. So I can plug it in. Area equals 1/2 times my apothem of 9.33 times my perimeter of 60, and I'm going to throw that in to my calculator, and I get about 279.9. And whatever that label was, centimeters squared. I think that's all I have for you. Please let me know as you have questions. Talk to you soon.